A rock from another star is passing through our sky right now, and almost no one on Earth will ever look up to notice it. 3i Atlas is older than our Sun, faster than anything our species has ever built, and in a few months it will be gone forever, erased from our night as if it never happened. We tell ourselves we are alone. We tell ourselves the stars are far, the galaxies are empty, the universe is cold and silent. But if a fragment of some distant alien dawn can wander across our solar system, unnoticed by nearly 8 billion people, how alone can we really be? We usually picture the universe like a giant vacant desert. Each star is an isolated campfire, each solar system a tiny circle of light surrounded by endless black nothingness. In that image, our Sun feels like a lonely outpost. Our planets are the only stones nearby. The space between stars is like a vast, airless ocean that nothing ever crosses. It is an easy picture to believe. From the ground, the stars look fixed, pinned in place. Our entire lives pass without seeing the sky change in any obvious way. But this quiet, still universe is an illusion created by our short lives and our slow eyes. If you could speed up time, if you could watch millions of years unfold as a single night, the cosmos would not look still at all. Stars would drift like glowing embers in a cosmic breeze. Clouds of gas would curl and ignite. Planets would be flung away. Whole systems would stir and collide. And through that restless, invisible traffic, objects like 3i Atlas would drift between the stars, like bottles thrown into a dark and endless sea. The simple idea is this. 3. I Atlas does not belong here. It is not a child of our Sun. It was not born in our planetary nursery. Its path gives it away. Instead of moving in a gentle loop around the Sun like the planets do, 3i Atlas races through on a wildly open curve, a hyperbolic track that never closes. It arrives from the direction of Sagittarius, near the center of our galaxy, dives past the inner solar system, brushes the orbits of planets like Venus, Mars, and Jupiter, and then escapes back to interstellar space, never to return. It is moving so fast that even the Sun's gravity cannot cage it. Nothing here could have kicked it to that speed. So the only explanation is that it began somewhere else, wrapped in the light of another star or in an ancient system that may no longer even exist. That is the first quiet implication. The space between stars is not empty. Somewhere long ago, 3i Atlas was part of a forming system. Maybe it was born in a disk of dust and ice around a young star, jostling with other frozen bodies. Over time, gravity tugged and pulled until something went slightly wrong. A close pass, a giant planet, a gravitational nudge, and this object was thrown out, exiled into the thin, dark medium between suns. Then it drifted, not for years, not for lifetimes, for distances so large that our language collapses trying to describe them. During that journey, stars were born and died, galaxies collided, worlds rose and froze and shattered, and this one silent traveller kept going, held together by its own small gravity, carrying within it the chemical memory of a system we may never see. Now, for a brief moment, its path and ours overlap. It cuts across the thin disk of our planets, threaded almost perfectly along their orbital plane, as if it had always been meant to skim through our celestial neighbourhood. That is the deeper implication. In a galaxy with hundreds of billions of stars, our solar system is not a sealed room. It is a hallway. Things pass through. And then comes the more unsettling, counterintuitive consequence. If a random comet from another star can wander through our skies, what else has passed by, unnoticed, before we knew how to look? 3. I Atlas is only the third object ever recognized as interstellar after Oumuamua and Borisov. That number feels small only because we are new to seeing them. Our tools have only recently become sharp enough, our surveys wide and patient enough, to catch these things in the act of crossing our stage. For most of human history, 3-eye Atlas would have slipped by completely unknown. No telescopes, no orbit calculations, no realization that a messenger from another system had been hanging, faint and silent, in our sky. The illusion of cosmic isolation begins to crack right there. We have mistaken our past blindness for the universe's emptiness. Imagine slowing time down around this comet. Freeze the planets, dim the sun, and let your mind float out alongside it. You are riding on a dark, frozen nucleus a few kilometers across, wrapped in gases and dust boiling slowly off as sunlight touches its surface. Behind you lie light years of traveled distance, a trail so faint no instrument could ever detect it, like a path through the water that immediately closes. Ahead of you, our solar system hangs in space, laid flat like a delicate clockwork. The sun in the center, the orbits of the planets traced as thin, invisible rings. From this vantage point, our proud world is a tiny blue whisper. All of human history, every city, every language, every war and love story compressed into a dot glinting in one narrow cone of sunlight. You, the traveller, do not slow down. You do not turn your head. You are not here for us. Your trajectory was carved millions or billions of years before humans learned to draw in the dirt. In that thought, the perspective shifts. We often imagine ourselves as the main observers of the universe, the central consciousness watching things drift past. But here, we are the background. We are a brief, local phenomenon in the life of something far older and more indifferent. This passing comet does not know it has become part of our story. Yet by discovering it, by calculating its path, by naming it 3-Pawn Atlas, we have turned its anonymous journey into a mirror pointed back at us. Because when we say, an object from another star is visiting, we are really saying, our star is not alone in launching stones into the dark. We are admitting that we are connected to a larger, unseen circulation of matter and gravity and time. And that raises a quieter, more haunting question. If fragments of other systems can reach us, could fragments of ours be reaching someone else? Think about what 3-Y Atlas carries inside it. Spectra taken from its coma, that thin, glowing atmosphere of gas and dust that forms as it approaches the sun, hint at unusual chemistry. Carbon dioxide dominates its activity. Metals like nickel whisper of a formation history in harsh, ancient conditions, maybe even in regions older than our own stellar neighborhood. Chemistry is memory. Every molecule, every ice, every grain of dust frozen into this object is a record of conditions around some distant star, its temperature, its radiation, its storms, its youth. From our point of view, this is just a faint blur in a telescope image, a streak on a CCD sensor. But embedded in that blur are answers to questions we are barely able to ask. What kinds of worlds form around other stars? How common are the ingredients for oceans, for atmospheres, for life? How old, really, is the material that now brushes past our sun? Here the consequence turns surprising. When we look at 3-Y Atlas, we are not just learning about some other place. We are sampling the galaxy itself. We are touching the shared material of the Milky Way, the same cosmic clay from which our own system was moulded. The illusion of isolation depends on the idea that out there and in here are separate. But an interstellar comet is literally a bridge between the two. It is as if the universe is quietly circulating messages in the form of rocks and ice, and we are only just now learning how to read the envelopes. There is another subtler illusion hiding beneath all of this. We treat events like 3-Y Atlas as rare visits, as if the universe is usually quiet, and occasionally something extraordinary happens to break the silence. But that sense of rarity might come from our limited observation time, not from the universe's behavior. Our telescopes have been capable of spotting such faint and fast-moving interstellar objects for only a tiny fraction of human history. The galaxy, on the other hand, has had billions of years, tossed debris and cometary fragments through every region of space. So, what if the Milky Way is constantly threaded with these wanderers? What if every star system is both sending and receiving material, trading icy fragments across light years, the way oceans trade driftwood across currents? In that picture, isolation becomes something like standing on a beach at night and insisting the ocean is empty because you only see the waves nearest your feet. Pet. 3. iAtlas hints that the galaxy is not a set of isolated islands, but a connected circulation, matter ejected here, captured there, altered, flung back out again, over and over. Our solar system might be holding pieces of countless other systems in its outermost regions. And some fraction of our own comets and rocks may already be wandering between the stars, carrying tiny samples of our sun's story into the dark. If someone somewhere else had eyes sensitive enough, tools sharp enough, patience long enough, they might one day notice a faint, foreign object cutting through their sky and give it a name. And, without knowing it, they would be studying something that once warmed briefly in the light of our star. Right now, as you listen, 3. iAtlas is moving. It has already swung through its closest approach to our sun. It has passed safely by Earth, at a distance far greater than the gap between us and the sun. No threat at all, just a visitor that barely noticed we were here. Most people will never know its name. They will never hear that a piece of another star system swept through their sky in their lifetime. In a few years, it will be too far and too faint for any telescope to track. In a few centuries, even the memory of its orbit will be a line in an old database, archived, forgotten, buried beneath new discoveries. But the comet will still be there. It will keep going, leaving our sun behind, as just another anonymous star in the background, another point of light it once brushed past on its endless journey. And somewhere, deep inside its frozen nucleus, the atoms will remain as they were, before humans, before Earth's continents, before our sun even fully formed. So what does that say about our loneliness? If even lifeless ice can travel from star to star, how confident can we be that consciousness is confined, that life hasn't already spread in ways we cannot yet detect? Maybe the illusion is not that the universe is empty, but that we have been looking for the wrong signs of connection. We search for radio signals and megastructures, while the universe quietly moves its messages in the form of chemistry and stone. As 3i-Atlas fades back into the dark, the question it leaves hanging is not, are we alone? It is gentler and stranger. How much of what feels isolated is actually in motion, secretly exchanged in pieces of itself, with everything around it, on timescales too long for us to feel? And if the galaxy is already stitched together by these invisible trades of matter and memory, what does that make us, standing here on one small world, just beginning to notice that the walls of our cosmic room were never really walls at all? If this kind of quiet wonder speaks to you, stay curious, keep listening, and let the next passing shadow in the sky remind you that even in the deepest dark, nothing is truly alone.